Hello everyone, welcome to another day 4 problem of the 30-day lead coding challenge. So the day 4 problem is move zeros. So the problem statement is given an array numbers, write a function to move all zeros at the end of it while maintaining the relative order of the non-zero elements. So let's say you have an input with with 5 elements. You should probably program it in such a way that you should be able to get all the non-zero elements of its relative order initially, and then we have to append all the zeros remaining in the input array. So this problem is quite interesting because of the constraint that we have of the relative order. We should not lose the relative order maintenance within the input array, and there is a note as well. You must do this in place without making a copy of the array. There should not be auxiliary space or extra space to be used while you are trying to get this solution. You should use the same existing array and try to minimize the total number of operations. Even the operation should not be much more. It has to be optimal enough to solve this problem. So initially we'll try to get the count of how many zeros available in the input array. For that, so this command would give us the count of zeros available in the input array. Once we get that, we check if this zero count is empty or not. It is not empty, then we are going to fetch everything available in the nums array and create a list comprehension, traverse through the array and get only those elements which are not zero. So this list comprehension would give us only those values which are not equal to zero. So this would, if you try to make an analogy with this input, this would return only the numbers 1, 3, 12 initially. Once you get this, then it is much more simple to extend this array with the count of zeros which we have got in the zero count variable. So you can actually extend the nums array by multiplying with zero count. So this would give you the additional zeros. This would give us the zeros available in the nums array. So let's try to submit this and see. Hope there are no syntax errors. Yeah, the submission has been accepted. So this is one way of solving this problem. You can try much more well. And by the way, there are few hints available in the move zeros problem statement section. You can go through them and see if you can improvise the efficiency of the current implementation that I have done. Now the current implementation would give you the runtime of 48 milliseconds with 14 MB, and it beats 73% of the submissions, which is quite good. And I hope this implementation is fair enough to start with to solve this problem. It can be much more efficient, I believe. Why? Because there are like around 25% of the submissions are which are having much more better algorithmic solution. Probably you guys can try over it, and I'll be coming up in upcoming videos. If I get more bandwidth, I will try to implement a much more efficient solution for this problem. So alright, I hope you have understood the implementational part of the move zeros problem. And if this is the first time you're visiting my channel, make sure you hit the subscribe button and click on the bell icon to turn on the notifications. Thank you so much for watching. See you next time.